Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss size and structure of atomic nucleus and its relation with atomic weight. Let's begin. According to Rutherford, the nucleus of an atom is very small in size, where practically we see whole of the mass and total positive charge of the atom is concentrated in that of nucleus. If we consider that be the atom, inside that of atom, in a very tiny portion which is very small as comparison to that of atom, that is called the nucleus, in which all the mass of atom is concentrated. In that of nucleus, there are proton and neutron. Around that of nucleus, electrons are revolving in that of orbit. So, proton plus neutron overall we call nucleon. Proton plus neutron overall we called nucleon. The mass of a proton and the mass of neutron is nothing but the mass of that nucleus. Therefore, mass of a proton, mass of neutron we called mass of nucleus. Again, since the contribution of electron, there is a definite mass of such electron, but in that of situation the mass of electron is negligible as comparison to that nuclear mass. Overall, since all the masses are concentrated on that of nucleus, so we call the atomic mass is exactly equal to the mass of nucleons. Since the mass of electron, mass of electrons contribution is negligible, so mass of atom, mass of an atom is nothing but which is equal to mass of that nucleus. Means mass of atom is defined as the mass of nucleus, that is the mass of a proton and mass of neutron. Overall we call it as nucleons. In technicality, how we define a atom? By its atomic number and mass number. We define an atom as atomic number which is denoted by the letter Z. Atomic number is what be the number of protons within that of nucleus, that is the number of protons in the nucleus, which show the atomic number of that atom, or anybody can say that is the number of electrons also in that of atom. As we say, number of electron is equal to number of proton in a particular atom, or it can be called number of electrons in that atom, as we call number of protons is same as the number of electrons in an atom. Overall, that atom is neutral due to the charge of electron is negative and charge of proton is positive. The number of electron present in that of atom is same as that of number of proton. So, overall that atom is treated as neutral. Again, mass number. Mass number denoted by the letter A. Which is referred as the number of neutrons and the number of protons. Since the mass of that atom is defined by that of mass of the nucleus, and the nucleus is nothing but proton and neutron. So, what be the number of proton and the number of neutron in that of atom, that indicates the mass number, that is the number of proton plus number of neutron. In this way, we define an atom with its atomic number Z and mass number A. Let us come to the size of that nucleus. Come to the size of that of nucleus. It is assumed that the shape of nucleus is nearly spherical. The shape of nucleus is nearly spherical. There are so many reasons behind the spherical shape of that nucleus, and we found that the volume of nucleus is directly proportional to the mass number. Mass number we call that is the number of nucleons. Number of nucleons means number of proton plus number of neutron of that particular nucleus. If we plot a graph in between atomic number and nuclear radius, so we get the graph like this. Due to increase in that of atomic number, the nuclear radius gradually increased. If capital R, that is the radius of the nucleus, having mass number A. Then as we found, the volume of that of nucleus is directly proportional to the mass number. Then volume of nucleus is directly proportional to that of mass number A. Here the shape of that nucleus nearly spherical and it has the radius r, so its volume 4 by 3 pi r cube, which is directly proportional to A, or 4 by 3 pi is a constant, therefore r cube is directly proportional to A. Now we use a constant term. So first r is directly proportional to a to the power 1 by 3, then r is equal to a constant r naught a into a to the power 1 by 3. Equation where r naught is equal to 1.2 into 10 to the power minus 15 meter, and which is called nuclear unit radius. Nuclear unit radius. From that constant value, it is clear that the size of that nucleus is of the order 10 to the power minus 15 meter. If we write it as 1.2, so 10 to the minus 15, if we write 12 into 10 to the power minus 16, like this. So the order of that nuclear size is around 10 to the power minus 15 meter. From this it is clear that the size of nucleus is of the order of 10 to the power minus 15 meter. Next, in nuclear physics, the atomic mass we define, that is the mass of nucleus, means mass of nucleons, proton and neutron. So that atomic mass or atomic weight is measured by a unit which is called AMU, atomic mass unit. A standard measurement we use to measure that atomic weight, which is AMU, and that AMU, atomic mass unit, how convenient. We define 1 AMU is what? Atomic mass unit is defined as 1 by 12th of the mass of carbon atom, 6 carbon 12 atom. This is the definition of atomic mass unit AMU. So what we the value of that AMU in terms of kg. According to Avogadro's hypothesis, the number of atoms in a 12 gram of 6 carbon 12 atom is equal to Avogadro's number. That Avogadro's number is 6.023 into 10 to the power 23. Hence, mass of one carbon atom can be calculated. Mass of one carbon atom, 6 carbon 12, is equal to, that is 12 divided by that Avogadro's number, 6.023 into 10 to the power 23. Under solving it, we have 1.9926 into 10 to the power minus 26 kg. According to our definition, 1 AMU is equal to 1 by 12 of the mass of carbon atom. Therefore, 1 AMU is equal to 1.9926 into 10 to the power minus 26 divided by 12, or 1 AMU is equal to 1.66 into 10 to the power minus 27 kg. 1 atomic mass unit is equal to 1.66 into 10 to the power minus 27 kg. That unit is used to measure atomic mass or atomic weight. Basically, that unit is preferred in case of nuclear physics. Next, nuclear density. The radius of the nucleus is very small, but this small nucleus is very massive. From that theory, we say that whole of that mass is concentrated on that of small region, which is called nucleus. That nucleus is massive, and that size of that nucleus around 10 to the power minus 15 meter order. Therefore, the radius of nucleus is very small, but this small nucleus is very massive. Since whole of the mass of atom is concentrated in that of tiny nucleus, the nucleus has very high density. We calculate the density of that of nucleus. Therefore, density of the nucleus is equal to mass of that of nucleus divided by volume of that of nucleus. Mass of nucleus divided by volume of nucleus. Mass of the nucleus, let we define capital M. Volume of the nucleus, let we define capital V. So, what is the mass of that of nucleus? This is the mass of nucleons. This is the mass of nucleons. That is mass of nucleons. Divided by volume, 4 by 3 pi r cube into atomic mass. A be the atomic mass, whereas A atomic mass number. Or which is called number of nucleons present. Similarly, the mass of nucleus, that is mass of proton plus mass of neutron. Or in other words, we can say mass of nucleons is equal to atomic mass number into mass of any of that of nucleons. So, mass of nucleons is equal to mass of any nucleon into atomic mass number A divided by 4 by 3 pi r naught q into A. Okay. Here mass of any nucleon, either mass of a proton or mass of neutron. So, mass of proton or mass of neutron, that is 1.67 into 10 to the power minus 27 A divided by 4 by 3 in place of pi 3.14, that value of r naught as 1.2 into 10 to the power minus 15 as previously derived whole cube into A cancelled out. That is the mass of nucleon, mass of any nucleon is equal to mass of a proton or mass of neutron, which is equal to 1.67 into 10 to the power minus 27 kg. Finally, we can solve it, and we have 2.29 into 10 to the power 17 kg meter minus 3, that is the density of nucleus. Look at the expression. In that expression there will be no such term of A, means atomic number is not there. Thus, the density of nucleus is independent of atomic mass number. Therefore, it is constant for all atoms. In case of each and every atom, the density of nucleus is a constant. So, here with the help of this video lecture, we understand the concept of size and structure of atomic nucleus and its relation with atomic weight. First, what is nucleus and atom? Its shape, r is equal to r naught a to the power 1 by 3, atomic mass unit, and finally nuclear density, and how it relate to that of atomic mass number. So, with this useful and informative notes, let me wind up the session. Thank you.